Okay, I think we can start. So hello and welcome. My name is Karol Harezlak. I'm a software developer. I work for a company which is called JFrog. You might be familiar with this company. Those guys came up with the Artifactory and X-Ray. And I'm also involved in Project Pyrsia. And today I'm going to talk about trusted decentralized package network in context of Pyrsia project. So my co-speaker today is Manas Das. He's gonna join us virtually in the sense that he pre-recorded some demos, and he will show you how to use Pyrsia in different scenarios. Before we start, a little bit of info and a few disclaimers. First of all, Pyrsia is open source and free. When it comes to disclaimers, I want to just make sure that some of the features and solutions presented today, they are not fully implemented. Many of those things I'm going to show you or explain, they're still in the either design phase or we're thinking about it to add it to Pyrsia at some point. Okay, let's look at our agenda. So first of all, I will explain what is Pyrsia and why anybody will consider using it. Then I will explain what does it mean that we implement this decentralized package registry model in Pyrsia. Next point in our agenda is how Pyrsia helps you to safeguard software supply chain. Then I already mentioned, then we're going to have a couple of demos done by Manas, and they are pre-recorded, so I'm just going to play some videos when we get to this point, and I'm going to switch between me talking about a different Pyrsia features, and then Manas will actually show you how you can use Pyrsia from a user perspective. For Q&A, please use Slido, code GeeCON 2022. I'm pretty sure that you're already familiar with this one because this is not a first session. All right. So, first topic on our agenda is decentralized package registry. I'm pretty sure that most of you, if not all, in the audience are familiar with tools like Maven, Docker, NPM, and so on. Those tools, they have very different purposes and they fulfill very different tasks, but what they have in common is they offer some sort of package manager respectively. So for example, what I mean by package manager, I mean like that they either offer or publish software packages or some binaries in some repository or registry, and they also allow you to download them either from your developer environment or from your continuous delivery or CI. So they have also another thing in common. They usually control by one organization or entity or corporation. So I would basically call them like a central authority repositories and registry. On the other end of the scale, we have decentralized approach, and this is what we're trying to do with Pyrsia. So basically in Pyrsia, we have lots of interconnected instances exchanging information about a Pyrsia network, taking care of distribution of binaries and software packages, and also those instances, which in Pyrsia we call nodes. They are responsible for sharing some events, sharing some logs, but I will get to details later on in my presentation. So another important information about Pyrsia is that anyone can participate. So you can run Pyrsia node on your local computer. You can run Pyrsia in your intranet. It could be Pyrsia node can be hosted in so-called cloud. pretty much anyone can participate, and more people participate, that is better for the Pyrsia network. So I already mentioned that the Pyrsia network using a peer-to-peer communication model, and that leads to the fact that because there's no central or one point of failure, it is highly available. So if a couple of nodes go down, Pyrsia network still can fulfill their tasks and provide packages and binaries. By the way, I'm gonna refer to software packages and binaries as artifacts in my presentation. Then introduces things like bottlenecks, and another important thing that is one of the unique Pyrsia network features is basically it's universal. What does it mean? It means that our goal is to support most of major package systems or types and ecosystems. Right now in Pyrsia 02, we support Docker images, so you can upload or request adding a Docker image to Pyrsia network, and obviously you can pull them from Pyrsia network. In next release, hopefully we will add Maven support. Actually, Maven support is already available, but it's in a prototype state. So if you figured out how to use it, you can probably even give a shot and try it in 0.2. Over time, we're going to add more package types like npm, maybe Conan, and so on. So basically, Pyrsia meant to be one place for most, if not all, your dependencies. So let's talk about what actually Pyrsia is. So Pyrsia, has two major elements. So first is Pyrsia CLI, which is a command line interface. It's basically a terminal tool which helps you to interact or configure the Pyrsia node of your choice. Usually it's your local Pyrsia node hosted on your, laptop or server. And then there's a Pyrsia node itself, which contains peer-to-peer engine. Some of the Pyrsia nodes, which we call authorized nodes, they contain build service, and also all of them are responsible for distributing so-called transparency logs. I will get into details about those elements later on in our presentation. So before I show you a demo, a few words about the Pyrsia CLI. So we do Pyrsia in general, Pyrsia node and Pyrsia CLI. It is supported on Linux, macOS, and Windows. So we have builds or installers for all of the mentioned operating systems. So a few examples of this terminal tool would be like if you want to configure Pyrsia node, you would execute Pyrsia configure from your terminal, so you can view and set host name for your node, port, storage limit, etc., etc. Actually, this is going to be shown in the demo. Another thing is that you can check the Pyrsia node status, so it will give you a feedback if Pyrsia is healthy, or Pyrsia node if it's healthy, and works as expected. And at this point, it's also worth mentioning that if you want to integrate Pyrsia into your CI/CD, there's not much. It's very easy. It doesn't require a lot of changes. It's also will be shown later on. So, okay, let's the first demo. So Manas will show you how to join Pyrsia network, how to use Pyrsia CLI, and how actually start a Pyrsia node on your machine. All right, let's see if this video going to work.
Hi guys, Manas here, working with JFrog in Pyrsia project. You already heard about the Pyrsia project, so it's my pleasure to have a talk on GeeCON Prague. So here I'm going to show you a demo on our toolset, which we developed as part of Pyrsia project, and this toolset is going to help you to join the decentralized package network. So as part of our 0.2.0 release, we decided to create a minimalistic installers for 3 platforms: Windows, Mac OS, and Linux. So here my demo is on Mac OS, and I'm using Brew. So we developed the installer using Brew Package Manager. With my assumption, you guys will have Brew already installed, or if you don't have, you can always install Brew or Homebrew. So my Brew version here, I have Brew 366 already installed on my machine. So what I'm now, I'll look for to tap our third-party repository, which is already published in GitHub. So just to show you the tab. So here is our third-party repo from where I'm going to install. So Brew in the background is going to install it from this repo. Okay. I have few outdated formula, but it's okay. So I already tapped into the repo, Pyrsia repo. Now I'll install Pyrsia. That's it. Okay. So Pyrsia got installed. So as part of the installation, you can see there is 2 binaries, Pyrsia and Pyrsia node is there as part of this installation. So here, these two tool set we are going to use to demonstrate how we are going to join the network, and then how we validate different things. All right. So I'll first check our Pyrsia installer version. Okay, so it's a 0.2.0 release, and on the another terminal, I'm going to run Pyrsia node. So before doing that, what I want to do for the purpose so that we have a explicit logging enough information available. So I'm going to set the log level here. So I set the log level for now for the demo to debug, so I can get enough information during the demo. And now I'll run Pyrsia node. Okay. I started my Pyrsia node. So what it is doing in the background, so it's basically connecting the peer node. We already have an authorized node in our network, and by using that Pyrsia node service, it's connected to the network. So you can see logs are coming, and how you're going to validate that you already joined the network. So on another terminal, I'll use Pyrsia ping. So it says connection successful. So basically, your node is now part of this decentralized network. And let's validate few other stuff. And you can clearly see, so from the logs that it's sending messages and it's dialing and dialing back. All these things is on my laptop terminal. So let's do list. So list shows about the connected peers. So right now the connected peers is, this is the peer ID, which you can see here. And what is, let's say, my config? If you wanna see the config. So it's running on port 788, and I have allocated 10 GB, which is part of the default installation. So this is the first part, how you going to join the network, and the installation guide is also available on our website. Windows, Ubuntu, and macOS, all these things are available here. So anytime you need help, you can always refer to that.
Okay, so that was the first demo. So you know that now you have a better understanding how easy it is to join Pyrsia network. And actually, at the moment you start running the Pyrsia network on your local machine, it means that you're basically part of the global Pyrsia network. There's not really much config going on here, so it's quite easy. Also, Pyrsia CLI terminal tool is also very straightforward. Okay, so that was the first demo. The first demo shows how to join Pyrsia network. The second demo will show you how to actually request new binary or package to Pyrsia network. And the third demo will show you how to use Pyrsia network in your tech stack or in your dev environment. So, but going back to build services and authorized nodes. So this diagram also shows the Pyrsia nodes, and the yellow/brown circles, they represent the regular Pyrsia nodes. Those are the nodes which are responsible for distributing artifacts and also transparency logs. But we have also a special case nodes, which we call authorized nodes. Those nodes are highlighted blue or bright blue. And only those authorized nodes have something which we call build service. Build service is a very broad concept, and it really depends on what package type we're trying to add to the Pyrsia network. So in case of Docker image, we will try to, for example, build Docker image from scratch, or if we can't, then we will default to Docker Hub. In case of Maven or Java packages, we literally try to build stuff from the scratch, and I will explain you why we do this, because this is very important, and that where the word trusted kicks in. But if we can build it, then we also will default to so-called trusted repository, in this case, Maven Central. So one disclaimer over here, this functionality, the authorized nodes are there, but we don't build stuff from scratch yet. This functionality hopefully coming in the next release, which is 0.3. Right now we're on the release 0.2. So why we actually trying to build from scratch? It's a lot of hassle. So you would ask, why are we trying to do this? You can just download stuff from Maven Central. You can use Docker Hub to get your binaries. But let's look at this diagram. This diagram is copied from a web page, which basically describes a framework, security framework slash checklist, which is called Salsa. And when you look at this diagram, you see how many things can go wrong if you do not control the whole supply chain, which means that I'm not gonna lie, we can't control every single point, even if we build things from scratch, but at least we can control most of them. So what would be advantage of actually building stuff on our own? First of all, before we publish something in the in Pyrsia network, we can do the static analysis of source code. Then, if there are dependencies, and in probably 99% of the cases they are, we can scan dependencies for vulnerabilities or security problems. And then, before we publish something in Pyrsia network, once again, we can scan this particular package and add all those info into transparency logs, which is available to every user in who basically uses Pyrsia network. So that's why we want to control every step. That's why, or most of the steps, and that's why we come up with Pyrsia. It's not only decentralized, but we also trying really hard to make it trustful. So we just basically came up with idea that if you can't control all the steps, you can't really secure it. I mean, we can't really control every single step, but we can control a lot of those steps. And I believe that we can the binaries and package and software packages we will host in Pyrsia network. It will be, you can trust them. They will be eventually, is once again this feature not available yet, but eventually we will also add a lot of info about the those packages in one place, which is transparency log. So once again, why are we doing this? If you attended the previous session, before this session, there was a lot of talk how to make sure that your dependencies are secured. So it is a lot of work, and people usually don't have time to do it. So what we're trying to do with Pyrsia, we try to automate those things. So you don't have to do it, but Pyrsia, to some extent, will do it for you. Okay, so another feature of actually build service is something which we called multi-node verification of builds. So if we build, or if we adding something to Pyrsia node and it's built from scratch, we don't build this once. We build this a couple of times. We will use, because once again, this feature is also not implemented yet, we will use several authorized nodes to make sure that the build result, it's basically adds up. So at the moment that authorized nodes agree to add something to publish or to publish it in the Pyrsia network, we want to make sure that it's, the build is reproducible in case that somebody, I don't know, hijacks our authorized node or something, and there is a differences in different builds. And at the moment that authorized nodes agree to do so, we add this to transparency logs. Okay, so this is how we handle, and partially will handle, adding a new content to a Pyrsia node. And now let's look at the scenario from the user perspective. So Manes will show you how to add a new content to Pyrsia node. And the example will be actually a Docker image. So let's watch this video.
Hi everyone, we are back with our second demo. The second demo is on how we can add artifacts to Pyrsia network. In the last demo, we already saw how we can install Pyrsia, and utilizing that, we seamlessly joined Pyrsia network, and we verify few stuff, whether we successfully connected to Pyrsia network or not, and what are the, let's say, other peers are connected to the network, their peer ID, and this kind of stuff. So move on to the current demo. Let me share my screen and let me show how we can add artifacts to the network. So doing that, we need to, let's say, right now we are supporting Docker images, and we are also working on Maven. So as part of 0.2.0 release, we successfully able to add Docker images into Pyrsia network. And just taking an example, let's try to add a bash image, let's say, into our Pyrsia network. So I'm trying a little old bash image here. Which is bash 3022. Let's try it. Let's see what happens. So it says build request failed. Oh,
So heads
so
up,
what is the
guys,
reason?
Pyrsia is still a new
So the
project,
reason
so
is,
we have
let's
bugs.
inspect the log on this particular thing. Pyrsia inspect log. Okay, so we can see what we are seeing here, that as soon as I inspect the log with that bash and the 3022 tag, I already found there is already something present in the Pyrsia network with this same thing. So which means we already have the artifact available in the Pyrsia network. That's why we got an error like this, which says there is a error. Yeah, definitely we are working on, but we are actually restricting adding the same image in the Pyrsia network again and again. So let's try something else. So let's try a different image. Maybe we can change the another image from the bash, maybe. Let's try. Let's change the tag name a little different. So 3123 is available. Let's try with that. Okay, I can see a little different over here. It says build request successfully handled and build ID 1 has been started. So that means this time I'm able to initiate the build in the Pyrsia network for this specific image. So let's try with the inspect log right now.
So inspect log is also, it means transparency log, where the info about artifacts are being stored, all kind of
So what
info.
does it say? Okay, I can see there is inspect log. So you can see there is inspect log. It says now we able to add the artifact 3122 in our Pyrsia network, and this is the timestamp when we able to add that to our network. You can see how we are storing our provenance log or transparency log for that particular image over here. So here we saw two use cases. One is once the image is already available, we are not adding it. And once the image is not available, we are able to successfully add the image into Pyrsia network. And also we can check the logs, the timestamp, and when it got added, we are keeping all the tracks on that image. So we keep on updating our documents on this, and we'll find the details on our website on these individual tags or JSON structure. Okay.
All right, so that was the example how you can add stuff to Pyrsia network or artifacts. Right now we support Docker, but it's also possible to the prototype, Maven prototype is out there. So Manas already mentioned transparency log. And let me explain what's the role of transparency log. Actually, this is another layer of security we're trying to implement with Pyrsia. And it's based on blockchain, so it means it's immutable and cannot be changed. And we keep all kind of, we're going to, and we already keep all kind of information in transparency log that guarantees that if something is published in Persian network, then you can't really replace it or hack it. You can't rely on it. And on top of it, transparency log eventually will provide lots of information about if we found any security problems with the source code, if we found any security problems with binaries or dependencies. So also stuff like where does binary come from if we didn't build it, who built this, what happens after what happened after it was built, any vulnerabilities, as I already mentioned, and we use blockchain to store that. So, once again, once it's there, it cannot be changed. We want to make sure that once something is published in transparency log and in Pyrsia network, then it is safe and you can trust it. So we're not taking the security lightly. It's not typical peer-to-peer network, but we really want to make sure that things we publish there or things that people request to publish there are secured and you can trust it. Obviously, to some extent, because most of the things is automated. So, yeah. So, a few things about a blockchain. Once again, is used to implement transparency log. We do this from scratch. It's lightweight, scalable solution. Some of those things are not implemented yet. We're trying to, implement a lot of things in Pyrsia. But as we progress, additional layer of security and functionality will be added to it. So stuff like multi-signature, Merkle tree, et cetera, et cetera. I'm not a blockchain developer, so I'm not going to deep dive into this problem. But if you have any questions, you can send me or send it to Shufe Hang, who is basically main developer on blockchain. And so one of the things that I didn't mention yet and about Pyrsia is that everybody's welcome to join either at the testing level, using Pyrsia network on a daily basis, testing it. If you a Rust developer or you want to learn Rust, please, join our meetings. Everything is open source and public, and you can contribute. So another thing, once again, I'm going back to security and trust because this is important. People hear peer-to-peer and they usually like, well, that's not going to be in any way trustful, secured. So Pyrsia aims mostly at open source projects. So one of the reasons is because if we don't have access to open source, we can't really analyze its source code. We can't really build it. So it is mainly designed and meant for open source project. Once again, it's a new project, so things might change as we progress. But once again, the idea is that if developers can depend on it. Another interesting thing, since this project is sponsored and mainly funded by JFrog, we have a lot of knowledge about security and finding problems in dependencies, software packages, etc., etc. So there is a product which is called X-Ray, and at some point we are hopefully will be able to utilize this ginormous X-Ray database to push more security-related info into transparency log. So basically, we will, instead of going to 7 different places or 5 different places, check your dependencies, check if the source code is secure, if your dependencies are secured, everything meant to be in one place in transparency log, and it's automated, obviously to some extent, but that's what we're aiming at. And eventually, if we decide to starting using X-ray, we also should be able to provide mitigation for this problem. So let's say there is a critical problem in your code, and Pyrsia tells you, oh, you have that kind of problem, security problem with your dependencies. We're hoping that eventually we'll also tell you, just do this and that, and the problem is solved. But that's the long shot. And the reason I'm telling this is that I want to just make sure that if you guys interested in problems like this, come join us, contribute to Pyrsia project. It's open source and free, and we believe that it will it might make an impact in the community or open source community overall. So if you care about open source, contributing to open source Pyrsia totally makes sense. All right, so we reached the point where I'm going to show you how to actually integrate Pyrsia network in your tech stack. It's either, right now, once again, it's either Docker or Maven. So Pyrsia network can act as a Docker mirror or Maven repository. There's not much to explain. If you're familiar with those config files, that's all you have to do. And we have a last demo, which basically shows how it's done. And Manas will show you how to integrate Pyrsia network into your Docker config and your local Docker configuration. All right, let's play it.
Hi guys, we are here again. And in the demo, we are going to see how we are going to use the Pyrsia network for our existing project, or how we can really leverage the Pyrsia network. So in last two demo, we saw the installation of Pyrsia node and Pyrsia CLI, which helps us to join the Pyrsia network seamlessly, also help us to verify whether we are part of the network, what are the other peer IDs are already part of the network, so on. In this another demo, we saw how we can add our trusted artifacts into Pyrsia network. Like we take an example of bash Docker image and we added it successfully. We also saw if image is already there, Pyrsia network was not letting us add that again and again. We also saw the transparency log. So in this demo, we'll see how we'll use the added trusted software or binaries into our project. So for doing that, we take the example of whatever we have added in our last demo, which is the bash image we have added. So let's say in our another project, we want to use the same bash image from Pyrsia. Just to make sure, I want to remove the image if it is already in my Docker cache. Okay, it was in my Docker cache because I was doing some testing, and as part of that, so finally, okay, I able to remove it. Now it shows, okay, no such image anymore. Now if I do a Docker pull right now, what will happen? It will by default pull it from Docker Hub, but I do not want that. I rather want to use the Pyrsia as a mirror, and the Docker images gets pulled from there. So to achieve that, I have to make some changes in my Docker. So I'm opening the Docker, I'm going to its settings, Docker engine, and I add here my registry mirror. So I have the value. So this is my registry mirror. Now how I boil to that value, boil down to this value, to the registry mirror. Okay, interesting thing. So one of my node is already part of the Pyrsia network. As you can see on the left top, the terminal, which is basically help me to join in the Pyrsia network. So basically my local machine become a peer into that network, one of the peer. And now let's see what is the configuration of my Pyrsia node. So it says port it's running on 7888. So from here, I actually deduce the value. If you see, my registry mirror says it's basically my local host and 7888. So when I'll apply that, what will happen in the background, it is basically pull the Docker image from my machine, which is already part of the Pyrsia network. So basically, eventually it is pulling from Pyrsia network. So let's see now. So I'll apply restarted. So it will take few seconds. So by the time how I'm going to verify it. So I already showed you that the bash image is no more on my machine or Docker cache. So I'll pull Docker pull for the same image. I'm not done yet because I have to wait till my Docker engine is coming up. And I'll validate from my node log. This node log, I'll validate. I'll see there will be logs which will show it got pulled from there. Okay, let me check this up. Okay, so it's got restarted and it's back normal, it seems. Okay, and you're good. So let's pull it and let's keep an eye on the log on the left terminal. Okay, so it's moving really fast. Let me do some select and okay, let me pull. Okay, so going up. Okay, I can see here is something. It says an artifact being pulled from artifact manager, and then finally I can see this thing, fetching manifest for bash with tag 3123, which exactly I requested from here, and it got pulled from the Pyrsia network.
Okay, so that's how you integrate it in case of Docker into your environment. Let's talk about what is under the hood and what are we actually trying to do and what technologies we're trying to use to implement Pyrsia. So we use Rust. We do have multi OS support. That means that you can build it in Linux, Mac OS, Windows. I'm not so sure, but I listed here because I don't know Windows. I hear that people were successfully building it, but not me. Then we used for peer-to-peer engine, we use Leap P2P Rust. Blockchain we implement from scratch. So yeah, let's see what features we thinking of. So latest stable release is 0.2, and I think it's already available, or it will be available today or tomorrow. So you can install Pyrsia, for example, using brew, and it will fetch 0.2 version. So what do we have in this version is, first of all, we support Docker. We have a Maven prototype there. We support a basic peer-to-peer implementation. There is a transparency log. We do have a pretty, that basic blockchain implementation, so transparency log is there. And we have something which we called cloud nodes for Bootstrap. It means if you start Pyrsia node on your machine, that it will automatically join the so-called global Pyrsia network. In release 0.3, what's important, we will try to deliver build from source for Docker and Java. That was the whole supply chain diagram I showed you, that we can make sure that things that we publish in Pyrsia network are really scanned, and we really care about the security and trust. Right now, we mostly default to so-called trusted repositories and registry, which is Maven and Docker, Maven Central and Docker Hub. The point 4, we want to improve our NAT support, so it works. So it basically works better in all kind of firewalls and transitions between the networks. Okay, so once again, if you want to get involved or read about Pyrsia Network, please go to pyrsia.io. That's our homepage. We also have a public Slack channel. It's part of this City Delivery Foundation. Look for channel Pyrsia. You can ask questions there, get involved, etc. Then we obviously have an open source GitHub project on github.com/Pyrsia. And I already mentioned that we are part of Continuous Delivery Foundation. All right, let's see if we have any questions. Is that room 4? I think it's room 4, right? Okay. What should I take from your talk when we use Nexus massively? I don't think I can answer that. I'm not familiar with Nexus that much, so come talk to me. What do you mean by that? And we can discuss this. So I'm not sure about it. Do I have a local node to get access to verified Pyrsia? If not, what is my motivation to run the node? Well, it's a lot of reasons why you want to run the node. First of all, it's about open source. So if you run your node locally, you're obviously contributing to Pyrsia network. You make it better, more stable, etc. We take so much from open source community. A lot of things we take for granted. So if you can run load locally, why not? I mean, I don't know. I can't really answer better these questions. Okay, what authorize nodes? Who authorized? So this is the thing that we didn't discuss. Authorized nodes, obviously, not everybody can run them. Authorized nodes will be more strictly controlled because, obviously, if we let everybody run authorized nodes, then everybody could add whatever they want to it. Once again, Pyrsia is few months old, so we don't have all the answers right now. But authorized nodes will be probably run by a bigger organization that they want to contribute to Pyrsia network. And I can come back to this question at some point and probably answer it better, but at this point, that's what we know. Which problem do the blockchain solve in the project? So blockchain, first of all, it provides our framework to make sure that no one can change the info we store in the transparency log. So you can't really go back, change like some signatures, change some data, then somehow sneak in the some binaries into and distribute it. So basically, it's about to make sure that you can't really edit the transparency log. What happens if the user try to build the same image? So that's not implemented yet, but when you trigger a build service and it is started, the authorized node starting to process that at this moment, we already know that something started. I mean, if that happens at the same moment, it's unlikely, however possible. I don't know I don't know how we protect this from the how we protect that kind of transaction from the implementation point of view, but yeah, that's the answer. Do you consider Pyrsia production ready? So it depends. There is a lot of challenges. Building some stuff from scratch, it is not easy. Once again, and as we progress, we will add new features. So production ready depends what you mean production ready. Like it would be rather if we support Docker, if we have a good enough support for Docker, then we will say, okay, Docker is super stable. You can use it. You can actually use Docker right now and add Docker images, connect to Pyrsia node, etc. How do you another question? How do you avoid man-in-the-middle attack when getting dependencies? So I didn't mention that, but ideally, what we would like to do with Pyrsia is that we will store or try to have as many dependencies inside of the network as we can. So we will rely continuously on the dependencies inside of our own network. And that includes transparency logs, that includes all the features that Pyrsia has. All right, I think no more, I run out of the time. So if you have additional questions, please come to me. I have a couple of Pyrsia t-shirts if you're interested, mostly in size S, unfortunately. And that's about it. Let's go back to the slides if there's anything else I should. No, that's it. Thank you for your time. And if you have any questions, please, email me or Manas, or just join the Slack and ask us. Oh, by the way, I didn't mention it. We also have public meetings every other week. If you Google it, you can find us, and actually you can join our public meetings on Zoom and ask questions there. If I didn't answer your questions as expected. All right, thank you.